In this video, I'm going to show you some examples of adding fractions. So our first problem is going to be 5/9 plus 1/7. I would encourage you when you're adding fractions to write them up and down vertically. 5/9 plus 1/7. That way you can do all your work out to the side here, and you can see all of your work and not get lost. So the first step that we're going to do, because these do not have a shared or common denominator, we have to find something that both 9 and 7 go into. I usually start with the largest digit here, the largest denominator, and count by that number and stop when I reach something that the smaller denominator goes into. So if I'm counting by 9, I will go 9, 18, 27, 36, 45, 54, and I'll stop at 63 because 7 goes into 63. So 63 will be my new denominator. And now I simply need to find an equivalent fraction for 1/7 with a new denominator of 63 and an equivalent fraction for 5/9 with a new denominator of 63. To do that, I'm going to multiply by some version of 1/2. And I'm going to box this off because in this box I need to multiply this by 1/2. When I multiply a number by 1/2, 1/7 times 1/2, I still get 1/7. So I want an equivalent fraction here that is exactly the same as 1/7. I don't want it to be changed. So if I multiply it by 1/2, I know it won't be changed. So I'm going to ask myself, what did I do to 7 to get to 63? And I multiplied it by 9. If I do the same thing to the top, 9 over 9 is equal to 1/2. So I know that I now have identical fractions here. They're just written with different denominators. Over here, I also want to multiply by some version of 1/2. So I'm going to ask myself, what did I do to 9 to get to 63? I multiplied by 7. If I do that same thing up to the top, 7 over 7 is 1/2. So I know I'm multiplying 5/9 times 1, so I should get 5/9. It just will look a little bit different. 5 times 7 is 35. I am adding, so 35 and 9 gives me 44. And my denominator is still 63 because that's what I'm talking about. I have my fraction's name is 63rds. So I have 44 over 63. This is the point where I will try to simplify if possible, but in this case, there are no common factors of 44 and 63. All right, let's try another example. Let's do 2/8 plus 4/6. Again, I'm going to write this vertically. And I'm going to show all of my work over on this side of the board. Alright, so I'm looking for a common denominator for 8 and 6. I'm going to count by my largest number here, 8. So multiples of 8 would be 8, 16, 24, and 6 goes into 24, so I'm going to stop right there. My new common denominator will be 24. Now what I'm going to do is try to multiply each of my fractions by some version of 1/2. So I'm going to say, what did I do to 6 to get to 24? Well, I multiplied it by 4. If I do the same thing right here, I'm multiplying by 1/2. 4 times 4 is 16. What did I do to 8 to get to 24? I multiplied by 3. As long as I do the same thing to the top, I will have 1/2 again, so 2 times 3 gives me 6. I'm ready to add this. 6 plus 16 gives me 22 over 24. Now I'm to the point where I need to simplify my fraction. And in this case, 22 over 24 is not in simplest form because they're both even. So I can divide the top and the bottom by 2 over 2, which will give me 11 over 12. Now notice that when I divided the top and the bottom by 2 over 2, I really just divided by 1/2 again. So I did not change my fraction. These two fractions right here are equivalent. But this is my simplest form answer. So 2/8 plus 4/6 in simplest form is 11/12. Okay, let's try one more example. Let's do 3/4 plus 2/3. I'm going to write these vertically. So I'm looking for a common denominator of 4 and 3. I'm going to count by 4s. 4, 8, 12. 3 goes into 12, so I'm going to stop there. And then I'm going to try to multiply each of my fractions by a version of a whole so that I have new equivalent fractions. 3 times 4 is 12. As long as I do multiply by 4 over 4, I'm not changing my fraction. 2 times 4 is 8. 4 times 3 is 12. And 3 times 3 is 9. When I add these fractions, 9 plus 8, I get 17 over 12. Now, my answer in this case is an improper fraction because the numerator is larger than the denominator. If I choose to, I can change this to a mixed number by asking myself how many twelfths go into 17, or thinking 17 divided by 12 equals what? And the answer to that would be 1 whole and 5 leftovers, so 1 whole and 5 twelfths. And 5 twelfths is already in simplest form because 5 is a prime number that does not go into 12. So these are some examples of how we add fractions.